To answer this question, for example, 18, we're going to set it up again using our constant of proportionality because I see that phrase directly proportional. So that makes me think I need a k when I see that in here. So I'm going to start out with if p, so that's starting my p is, there's your equals, directly proportional to the square root of s. All right, that's different than the square of s. The square of s means you're putting an s with a little 2 up there. The square root means we're using this symbol here. Right. Then we do exactly as we've done before. Plug in your next set of data points or data information here. P is 12. S is 4. The square root of 4 is 2. And then solve for k. So divide both sides by 2, and we're going to get k is 6. So that's just my proportionality constant. I plug that 6 back into my first equation. P equals 6 square root of s. Then I use that equation to answer this last part here. Find p when s is 16. So p equals 6 square root of 16. And then you can either type it into your calculator or do it in your head, however, but the square root of 16 is 4 times 6, 24. For the next example, it's a word problem, but the idea is still the same. The distance d is directly proportional to the square of the time t it rolls. All right, so let's start out. D is directly proportional to the square, not square root, but square of t. They give me some information here during the first second, so that's when t equals 1, the ball rolls 8 feet. D equals 8. So plug that in to solve for k. K times 1 squared. Well, that's not going to be too exciting because 1 squared is just 1. So k equals 8. So then plug that back in to get your equation. D equals 8t squared. From here, we're going to use that to answer part B. How far, so we're looking for distance, does the ball roll during the first 3 seconds? So your t is 3. But don't forget, you're going to square that 3 because that's part of your formula. And you come up with, and again, you can just type this straight into your calculator if you're not comfortable with your arithmetic, but it comes up 72, and then the unit labels on distance, you can go back up here and read, distance was in feet. So 72 feet. For example 20, they're giving you a formula, area of a circle. Area with respect to the radius is pi r squared. Now we want to evaluate a of 4r, which means we take out the r, and then we're going to replace that r with 4r. So a of 4r equals pi, take out the r, and put in 4r. Multiply or raise each to the 2 powers, so it's going to be 4 times 4 or 4 squared. So we have pi times 16 r squared, or 16 pi r squared. Express your answer in terms of A, the original area. The original area was pi r squared, so pi r squared is just my A. By what factor does the area increase if you quadruple, that's what we did here, quadruple the radius what happened to my new area? Well, it increased by a factor of 16. That's how much it changed from the original. Our original was just pi r squared, but we ended up with 16 pi r squared. So that's why we're getting this increased by a factor of 16. Number 21 is similar to that. We're starting out with the volume of a spherical globe is 4/3 pi r cubed. Instead of r, though, we're going to put in 3r. So we're tripling the radius. All right, we're going to see what happens to the volume. So v of 3r means take out the r on the right-hand side of the equation and replace it with 3r. Do just like we did before. All right, raise everybody inside to the third power. So it's 4/3 pi. And then there's a 27 now, 3 times 3 times 3, and then r cubed. Express your answer in terms of v. Our v originally was 4/3 pi r cubed, but now we've got this 27 stuck in front. So we're going to pull the 27 out in front. We still have 4/3 pi r cubed. And our 4/3 pi r cubed was really our v. So by what factor does our volume increase if you triple the radius? When I tripled the radius, we ended up increasing by a factor of 27. So we increased our volume by a factor, that's what you're multiplying by, 27. This next example goes back to, again, setting up your basic equation. If current C is directly proportional to voltage V, all right, now we got to go back and find K, and they gave us the information up here at the very start with this sentence. It's connected to a 220 volt battery, so that's my V. And it's 50 amps, that's my current. So divide by 220. All right, so now here's the thing. If I take and pull up my calculator, I'm probably going to pull up about 3 of them because I hit it 3 times. Yep, there we go. Let's get rid of that one. And that one. Let's see how many more we got. Okay, just that. All right, so if I take 50 and divide by 220. Notice I get a big long decimal that's, doing all kinds of craziness. And rather than give an approximation to this, because it doesn't say to round to so many decimal places, I'm going to leave it then as a fraction. So if I go into math and then hit enter twice, it'll reduce my fraction down for me if I didn't want to. So I'm just going to leave K as 5/22 for right now. If it had been a terminating decimal, in other words, one that had a definite ending, then I would go ahead and write that. But since it was a big old long repeating thing, I'm just gonna leave it as the fraction. Go back in, plug that fraction in. And then answer the question here. What voltage, so now we're looking for V, is needed to produce a current of 75 amps? So 75 is the C, equals 5/22 times V. You could divide both sides by the fraction. It's going to get a little clunky taking a number divided by a fraction, but you could do that. You could also just multiply by the reciprocal, 22/5, and that'll cancel it out on this side and do the same thing over here. So again, if I take my calculator and take 22 divided by 5 times 75, I get 330. So V equals 330, and the unit label on that is just volts. So again, if you'd have decided to divide both sides by 5 over 22, take 75 divided by, and then use parentheses 5/22, it would also come out to 330.